the relationship between degrees and radians is that if this is 180 degrees and all the way around is 360 degrees, and all the way around the circle, the distance around the circle is 2 pi times the radius. So in the unit circle, if you let the radius be 1, then the distance around here is 2 pi. So that means that pi has to be the same thing as 180 degrees. So if you have something that's in degrees, to write it in terms of pi, we know that pi has to equal 180 degrees. And I linked up a video on exactly what a radian is too, because a radian is not always written in terms of pi. So write each measure in radians. So we have something in degrees, we want to write it in terms of pi. So if we know that pi is 180 degrees, we can think of a proportion as 45 is to pi radians, or radians, as 180 degrees is to pi. So if you cross multiply, you're going to get 45 pi equals 180 r, and then you're going to divide both sides by 180, and you'll reduce 45 over 180, which is 1/4, so you'll get pi over 4. So the shortcut is divide this by 180 degrees and then multiply it by pi. So 90 divided by 180 degrees is 1/2. So 1/2 times pi is pi over 2. Or you can think about on a unit circle, if this is pi, then half of pi is 90 degrees, so it's pi over 2. So this is going to be 30 divided by 180 times pi. So 30 divided by 80 is 1/6, so it's going to be pi over 6. This is going to be 150 divided by 180, which is 5/6, and then times it by pi, so 5 pi over 6. This is just going to be pi. 80 is going to be 4/9 pi. 110 is going to be 11/18. So all I'm doing is reducing 110 over 180. So 11/18 pi. 8/9 pi. 10/9 pi. And 11/9 pi. It's just reducing fractions over and over again. So you can either write the pi in the numerator, like 11 pi over 9, or you can write it as 11/9 pi. It's the same thing. Just make sure to not put pi in the denominator. So down here, to write in degrees, what you're going to do is you're going to multiply by 180 and then divide by pi. See, up here we divided by 180 and multiplied by pi, but this time I'm going to do the opposite, or the reciprocal of it. So these two will cancel out, so pi is the same thing as 180 degrees. So this is going to be 2 pi times 180 divided by pi is going to be 360 degrees. And then 5 pi, so 5 times 180 divided by 6 is, these two are going to cancel out, and you're going to get 150 degrees. So you do this over and over again with the pattern. Now these all have pi's on it. Sometimes you have questions of write something that's just without a pi, it's just 7 radians. So you're still going to do the same thing. If you have 7 radians and you want to convert it to degrees, you do 7 times 180 and divide it by pi. And that's going to give you your number of degrees. So you're still going to multiply it by 180 over pi. So realize that this is going to be an irrational number because you're dividing by pi. Here you divide by pi, but these pi's cancel out. That's why you got a whole number for these answers. But if you just start out with like 5.2 radians, you're still going to multiply it by 180 and divide that by pi. Just like we did exact values of sine and cosine with degrees, you can do the same thing with radians. So you can either think about where pi over 6 radians is on the unit circle. So if this is 180 degrees, if this is pi, and you cut this into 6, 1, 2, 3, 4, 5, 6. You have 6 pieces in half of the pi. Each of these has to be equal to 30 degrees. So essentially, what you're doing is you're doing the exact value when it's 30 degrees, which is the same thing as pi over 6. So to find the exact value, you always want to drop down to make perpendicular with the x-axis. Then you're going to label it, this distance is a half, this is a unit circle 1, and this is root 3 over 2. So you remember that cosine is the x and sine is the y. So the cosine is 1/2 of pi over 6. The cosine of pi over 6 is 1/2, and the sine is root 3 over 2. And they're both positive because they're in the first quadrant. So the second one, pi over 3. So if you think about pi as half a circle and you're cutting that into thirds, you're going to end up with 60 degrees. So now I'm going to draw a 60-degree reference triangle. So make sure that this makes a 90 with the x-axis. This is going to be 1/2, and this is root 3 over 2. In the unit circle, the radius is 1. So since we're both in the first quadrant, cosine is going to be positive. Oops, I realized I did this one backwards. Oop, these are right, but not how I wrote it. This should have been right here. These two should have been flipped because I went over 1/2, or over root 3 over 2 and up 1/2. So these two need to be flipped because this one is going to be over 1/2 up root 3 over 2. And they're both positive because they're in the first quadrant. Cosines, or x is positive in the first quadrant and y is positive in the first quadrant. Now negative 3 pi over 4 radians is you take pi and you cut it into fours. So this is 1 pi over 4, 2 pi's over 4, 3 pi's over 4, 4 pi's over 4. But in this case, you're going in negative, so I'm going to go this way. So actually, negative 3 pi over 4 ends up right here. So I'm going to make up with my x-axis. And now I have my reference triangle. This is a 45-degree triangle, so it's going to be root 2 over 2. And this distance is root 2 over 2. So the cosine and the sine are both going to be negative in here because it's in the third quadrant. So this is negative root 2 over 2 and negative root 2 over 2. Now let's go to 7 pi over 4. So 7 pi over 4. Think of cutting it into fourths again. 1, 2, 3, 4, 5, 6, 7. So 7 pi over 4 is going to be all the way over here, which again, this is your reference triangle, and this is 45 degrees. The radius is 1, this side's root 2 over 2, and this side's root 2 over 2. So in the fourth quadrant, your cosine is going to be positive. So it's going to be root 2 over 2. And your sine you're going to drop down is going to be negative root 2 over 2. If you want to, you can always convert 7 pi over 4 to degrees, if that helps you. Okay, so 5 pi over 6. So you take your circle, and this is pi, and you cut it into 6. So 1, 2, 3, 4, 5, 6. the resultant triangle is going to be a 30-degree triangle. So then this is going to be root 3 over 2, and this is going to be 1/2. So the cosine is going to be negative root 3 over 2 because you're going backwards, and the sine is going to be positive 1/2 because you're going up. So the x is negative and the y is positive. And then 36, 4 pi over 3. So take your pi, cut it into thirds. 1, 2, 1 pi over 2, 2 pi's over 2, 3 pi's, or 1 pi over 3, 2 pi's over 3, 3 pi's over 3, 4 pi's over 3 gives you a 60-degree angle. So this right here, if this is a 60, this has to, I didn't draw this very well, but this is your 30, this is 1/2, this is root 3 over 2. So you're going to go left half, so it's negative 1/2, the x is negative, and you're going to go down root 3 over 2. So again, with these, you can do the last two, but you need to finish, you need to either convert these to degrees or think about how the pi's are broken up. Okay, 45. A pendulum swings through an angle of 1.8 radians. So you have this pendulum, and the angle is 1.8 radians. The distance the tip of the pendulum travels is 32 inches. So pendulums go back and forth in a circular motion. So what we're going to do is we know what the arc length is. We know that the arc length is 32 inches. So arc length is equal to the circumference times how much of the fractional part of the angle that you're working with. So if this was a degree, we would do this degree divided by 360. But this is in radians, so I'm going to do 1.8 and divide it by pi. Actually 2 pi, because the whole thing is 2 pi around. And it's in radians, so that's why if it was pi over 3, you would just do pi over 3 divided by 2 pi. But we know the arc length is 32, so I have 32, but we want to know the length of the pendulum, so we want to know the radius. So these two cancel out, and actually these two cancel out. So now you have r times 1.8. So we divide both sides by 1.8, and you get the radius, or the pendulum length, is approximately 17.78 or 8 inches. So arc length, excuse me, is the circumference multiplied by the fractional part of the circle that you're referencing. So 46 is this time you know the length of the pendulum, so you know that the radius is 0.8, and it swings through 1.5 radians. And this time you're trying to find the arc length, trying to find that distance. So this is radians, this is meters. So arc length is equal to 2 pi times the radius, which is 0.8, because that's the length of the pendulum, times 1.5 radians divided by 2 pi, because that represents the fractional part. So you can put that all on your calculator, and it's about 1.2 meters, rounded. Actually, so these pi's cancel out, 2 times 1.8, 0.75, 1.2 meters.